Okay, we're up. So where I have got to is I've made a document that should have published on the website that talks about IPFS. Let me find you a link.
What section?
Under drafts, IPFS.
Don't think I made it up yet.
What? Yeah, man, it's there. Under NFA's drafts, IPFS.
Right, so there's more than one draft.
What? What do you mean? Oh, does Docs have a draft? Yeah, okay. My bad.
There it is, okay. How did they not have any way of like checking the contents, like of embedding permissions inside the contents?
Buddy, you fucking tell me, because I'm like, that's like the easiest, the greatest, the most usefulest of all the things, right? They could so easily do it, and yet they don't.
That hook would take like 4 lines of code to write.
What?
And then you could supply your own from like it's literally just like call a function on this.
Yeah. That's basically it,
After
right?
you
Like,
read it out.
hey, here's what I got asked for. Here's who it came from. Can I talk to them about it, right? That's all the hook needs to be.
Mm-hmm.
Yeah.
And you could make it so that anybody could make their own too, right? Like I don't know. It's funny.
Well, so what it turns out, the overview or the background of where this document came from was that IPLD, and given the millions, literally millions, that we spent on R&D to figure out the best way to build this thing, I'm kind of horrified that none of us delved into the internals of IPFS and was like, this is a great starting point.
We talked about that in Calgary for sure. Like everybody there was a big fan of IPFS.
Yeah, but we didn't see how to, I think, turn it into something that was native.
Right.
You know, like we were like, oh yeah, let's use it like this sidecar. But now that I got a running system, I can and the problems that I've hit when I've tried to have like 20,000 customers dangling off of one collection chain. Now I understand how to use IPFS on the inside, so that we're like sort of technically one layer below IPFS, because that's where IPLD sits. IPFS sits on top of IPLD. IPLD is way more general. Like it's beautiful in how it works and how general it is.
This is not even really a like code. This is more of a protocol, hey?
IPLD?
Yeah.
It's a data structure with some implementations that you can use. And then what IPFS does is it marries libp2p along with IPLD, and then uses it to present a files abstraction. But sorry?
I don't think that the documentation was in a clear enough state to understand like these pieces this well back then.
Yeah.
Like I remember downloading IPFS and being like, there's a lot of pieces here and I don't understand what most of them are doing. But yeah.
It's still like that. I mean, I just spent the last fucking every waking moment for the last week researching this thing, and the pieces we need are not obvious from the outside.
Yeah.
But and it's also with analyzing how the software package works, particularly in the browser, like looking at where does it store its stuff, how responsive is it, how does the architecture of libp2p work? Is there going to be unnecessary latency? Can we have enough control over it so that, like, if we're trying to look up a value, can we exit early, or do we need to wait for a value to come back, or like all those kinds of things, right? And with the view of we want to actually override as little as possible. So from the point of view of the discussion I wanted to have with you, I wanted to split permissions out into a completely separate problem because I believe it's independent.
Okay.
And the reason I believe that is because IPLD provides a set of tools called selectors, which allow you to define a path that you can walk in a hash-linked structure, and ways to make decisions about where you should walk next. And so the general, sorry.
Okay. Yeah. Sorry. I'm not.
The general principle that I believe the most utility for permissions can be achieved is to provide a way to let developers specify a selector and a way to insert a yes/no hook. So basically, if a node asks for a hashed piece of content, you would use the selector to walk from that piece of content. If you had it, you may need to walk across arbitrary other pieces of content that you'll have to fetch. So for example, if I want to gain access to a customer's address, then the selector would tell me how to walk up to the app root and then walk down to the ACL chain and then look up in there, is this person who is the public key that just requested this information from me granted access to it by this content that I just looked up? And so the key there is that the content must specify who has access to it. And you can do that in a fairly generic way with these selectors that define a path and then a hook that just decides yes or no. And the most general sense can just be reading from a list of public keys. If you're not on the list, sorry.
Yeah, I think MVP here is definitely like always the same spot in the block and always public keys.
Yeah, but no, that's like version 1. You mean MVP of the permissioning system?
Yeah.
Yeah. So that seems not easy, but it seems reasonable to achieve. But it's modular is the main thing, and that's why. So the shortcut that I wanted to take in the meantime was, well, look, let's just define you only need that system when you want to have overlapping permission groups. But if you have completely exclusive permission groups, you can use a feature in IPFS called a cluster key, where you can basically say, I'll only talk to people with this cluster key, so a shared secret on.
Oh, okay.
Right. And so
is that like a multi-sig basically?
Nah, the key is just a secret string.
Right.
It's just for running your own private network of stuff. So for usage as a CRM, that's fine. The company's okay with that. For usage on the Dreamcatcher for the web liquidity pooling, everyone being able to see at the start, that's fine too. So I just figured it allows us to bring forwards launch. All right, so the things I wanted to double check with you was basically what I put in that doc. around the signaling mechanisms and the tree structures that I want to implement and go through. The two most interesting or controversial structures, I imagine, are the fact that I want to change the notion of blockchain to block tree.
Mm-hmm.
And I want to have an overlay tree that I've called the turnover tree, which is a tree that only contains blocks where the validator set changed. So, because, for example, like if you come late, you get the latest block, you know the chain ID, and you want to verify it, you don't want to fetch the whole blockchain, but you do need to know when the validator set changed so that you can verify the signature on the latest one. And so using this turnover tree, you'd be able to rapidly walk to all the blocks that included turnovers, turnover events where the validator algorithm or set changed, or some other critical piece of config that you'd need to know to interact with this chain. And then, off you go. And the reason I wanted to make it a block tree was that in a truly distributed system, I want to avoid having a protocol of any kinds, which was always my goal with interblock. Like, that's why I got rid of the enveloping protocol that I'd made to send messages back and forth, and was like, it should be only interblocks. And then if you want to do some interaction between nodes on top of that, you should do it inside a chain, so that the only protocol software we have to write is interblocks. Right, but with IPFS, the main query that would become difficult would be get block by height. So you would have to walk one at a time to learn the hashes of each one. Whereas if instead of calling parent the hash of the previous block, we'd rename parent to be the root hash of a Merkle tree that contained all the blocks as leaves, so that you could do instant or very quick height lookups, where you get like log performance for number of blocks. So that's a good enough, log's better than n, right? So, winning. And additionally, inside of IPLD, they let you make different shaped trees for different purposes. So you can actually make a DAG called trickle, which is where like the latest block you add is always an immediate child of the root, and everything prior, so it's like it's unbalanced. So it just makes lookups are quicker to blocks that are more recent.
So the DAG is the metadata. The DAG is the metadata here for verifying the block. Is that?
The DAG is
like it's the Merkle tree.
It's the Merkle tree, yeah. Well, yeah,
okay.
It's the Merkle tree, but you can make like a non-balanced Merkle tree. So like a trickle Merkle tree has a good property for blocks, I think, because you are more concerned with the latest blocks as opposed to the first block. But as far as
sorry, the DAG is the real data. There's still a Merkle tree on top of the DAG, right?
No, that is it.
Okay.
So that's why like we need to shape it carefully, that's the piece that makes us native to IPFS, because
Right.
the internal structure of the blocks I plan to represent using their IPLD data model and using a DAG that's built up using their primitives instead of ours. And so by being native to them, we fit in with their tooling better.
Yeah.
And there's less for us to maintain, which is always good.
I'm just looking at a visualizer for this.
The IPLD.
The trickle DAG that you're talking about.
Oh, yeah. Trickle DAG's awesome. So basically, because we're using this DAG tooling, first of all, we have the trickle DAG that represents all the blocks in the chain. And then secondly, we have this turnover DAG, where that represents a quick way to look up when validation changes occurred.
Right.
As like I think it's totally fine that within a block you have like multiple hash references, like a hash to the root of the trickle DAG as parent, and then like the left node of parent could be the root of the turnover tree. So you can build like you can have you can pick your number of nodes that you want at each level in the DAG. Basically, so like because I basically want a turnover tree that points to some of the same elements as what the chain tree points to, and so it's really just pointing a different way. And the really good thing about the way these DAGs are built is that when you define a link, the hash of the link includes the hash of all the things that it pointed to. So that's why choosing the design of the tree is the most critical thing for us.
Okay.
Like it needs to slot. We need to cut the block structure nicely so that it coordinates with their concepts, which I think it does pretty easily. And then the third structure, I know I said two, I forgot about this other one. The third structure is an intriguing one, because on any given channel, what I've been doing is storing the hash of the most recent interblock that I received. In the IPLD system, all I would need to do is store a reference to the hash of the block, because I had been treating an interblock as a different object to a block. But under this DAG system, you could treat it as exactly the same. So you'd have in your channel, you'd have a link out to this foreign chains block, the last one that you saw. And then under the permissions model, as you try to ask for the nodes that come below the block so that you can dig into the network and get your piece, you would only be permitted to retrieve the paths that your chain had access to, because you're asking on behalf of your chain.
Right.
And so when you get them, you haven't been exposed to the rest of the contents of the block, but it made interblocks go from something that is transmitted to just read access to a part of the block. So it transformed a network event into a file system event, which I goddamn love.
Mm-hmm.
And And so these block structures start to look more like links in between blocks. And it's the permissions layer that makes them into interblocks. So basically, it totally demotes an interblock away from being a thing of its own right and into just like a part of a block DAG, which was what it was supposed to be, but I turned it into a transmittable thing because the network layer was my concern up until now. Now, with IPFS, the network layer, not my problem.
Great. Let me repeat back to you to make sure that I got it.
Okay.
Like, you used to basically separate the channels off of the block when you were done making the block, and like they have their own separate life cycle, basically, right?
Yes. Yeah.
Yeah. And now, like, because you can, so what you're saying about selectors here, where I'm saying let's just put the public keys in the same spot all the time, like that's not correct. Like it's better to put all sorts of data at all sorts of different paths because it's a pretty native operation in IPLD to like do a lookup on a specific path. So
Yes.
as long as we have like a really structured mechanism of putting the channels in the right place, it's actually an IPLD native operation to make two chains communicate with each other.
Yeah, man.
Yeah, that sounds like a huge win.
Huge. Like I still can't properly get over it. The amount of effort and like we'd always punted this problem out. We're like out. And now that we're ready to tackle it, it's like pretty much already solved for us.
Well, yeah, that's great. What is it going to take to modify the existing system? Is this another restart, basically?
Nah, man. It's really not. The reason why I had the model system was to basically allow queries on objects, so I could like encapsulate the types of questions I wanted to ask of an object in the object itself, which made it easier to reason about the system. All that's changed, and then when I told you I was redoing the model system, all that I was doing was turning the data that backs them from an object into an array, which stripped out the JSON keys, the keys in the JSON, so it was more compact. But the reason I did that was because I built a Merkle tree on top of that backing array. So all I got to do, I think, is swap out that backing array for an IPLD compatible array, which seems, I don't know, call me naive, seems like a couple of days.
This documentation is dense.
I know, dude, but I think it's actually very straightforward to do the conversion because I was already halfway there with the Merkle tree. So every object is already backed by a Merkle tree. I just need to change the thing that's calculating the Merkle trees.
I'm at this Explorer IPLD. They call it the Merkle Forest.
Yeah, I know.
I appreciate that.
It's a beautiful set of concepts. I gotta say, it took me a while to even know that that's where I should be looking, because I started looking at libp2p, and then I was like, oh no, wait, maybe we fit even better. Maybe we can fit in IPFS itself. And then I was like, what's this IPLD thing? And then that's when I was like, wow, like just wow, like.
Of course, it's already solved.
But it's solved in a way that, so for example, there are translators in there that let you load Git repos directly using the IPLD tooling.
Oh my God.
Right? You
So, like, commits are basically already part of the blockchain.
They have backwards compatibly said that actually our schema is the schema for anything using hash-based linking.
Mm-hmm.
And so they're like, Bitcoin, come in, Git, come in, ETH, come in, all these things, right? And the awkwardness is that those things, because they aren't native, you can still sort of see this wrapping layer around them.
Mm-hmm.
And so for us, we'll be truly native, so there will be no wrappers.
So I'm looking at the multi-formats library now.
That's a great. Turns out that that's what I'd already been doing. Because if you look at something like where I'd made the integrity object, I'd made it so that you had to declare your hash type as a string that was from a set of enums, and then you had to put your value in. Like, they've already solved the thing I wanted. Like, I remember having fights about this back in Calgary when I was like, no, you should be able to change your hash algorithm. It shouldn't be baked in. Like, they've done all this fighting for us and put it in a table and been like, here's your format table, and as life goes on, we'll update it. Perfect.
Yeah, I'm actually pretty excited.
But the thing that I'm super excited about for the web liquidity pooling is that right from launch, we'll be able to have native Git integration. So all I'll have to set up is a GitHub action that triggers when you do a commit that just simply wraps the Git commits in the IPLD wrappers and then pushes them to IPFS and updates a chain, aka a file. And then we can even, within our own application, natively browse the file contents of the Git repo, as well as browse the binary layer of any of our chains using their existing tooling. Like if you put an image in there, kind of just shows up. But there were some other trees that I wanted to talk about too that I'm contemplating implementing, not because I like making trees, but because I like saving time. And so I think that a block is a wrapper around 3 trees already, ignoring the provenance tree, which is like the pointer back to where did I come from, what was my parent. So ignoring ignoring that provenance link, the 3 trees a block contains are, number 1, the state tree of itself and its children, the liveliness tree of itself and its children, which is all the channel activity, which actions got processed, where am I with my links to other chains, what's the configuration of my system slice, the DMZ, all that stuff. And then the third tree is the binary layer tree. And I think that by virtue of the IPLD data model, we can present to applications these trees in their shortened version. So for example, if I want to look at state, as I've got my app, it's got 20,000 customers, give me a massive MongoDB-like view of just the state, then that's that tree. And so, for example, I am intending to implement the protocol that when the state changes, in a child, it causes the hash of the state tree to change in the parent. And so that when you're looking at the root of any app, you should be able to say, well, this is the hash of the state, this is the hash of the binaries, and this is the hash of the liveliness, which means that you can simply look at that root and know that the state hasn't changed from block to block to block, but the liveliness did, because otherwise, if you look at it now, it's opaque to you because blocks change, they have new hashes, but you may not care about the liveliness, you may only care about the state. And the question I have for you, and this is sort of the conundrum, is the binary layer really an extension of the state tree? And so if there's a deeply nested child whose binary payload changed, would you have expected that the state hash of the app root would have changed as well?
I mean, I think that makes a lot of sense. The state hash, not the... So, like, I guess the main thing to me that the parents are really tracking is references to children, right?
Yeah, but I also wanted to split out references to what part of children, and I wanted to make a difference between the state versus the metadata, which is the block's maintenance, which can be altered by fucking anything.
Mm-hmm. Well, and it would be all the time. I mean, I don't know if you have any sort of like strobe-like event that you still want to have happen on the chains, but
yeah, there is, but strobing is done by connecting to a service.
Right. And so it's somebody else still externally hitting you. That makes sense, actually. Yeah, but like assuming that most chains are going to want to have some sort of like cron-like system somewhere, or most chain complexes, I guess. Like then you're going to constantly see.
Great name. It's a great name.
Yeah. You're gonna see a lot of churn and metadata on the chains all the time.
Yeah. But I wanted to separate out state because, like, who cares about the metadata as a consumer of the app? I just care that the state is correct and available.
So are you talking when you're rolling up the state hash, like through the layers, like? If you had nested parents, I guess, or nested children, like, would it just be the state hash of the middle child, like, going into the state hash of the parent, the top parent? Like,
I would imagine it was like you'd have your state, and then the tree, the Merkle tree, representing the state hashes of all your children, and then that would roll up to represent your state hash that you present to your parent.
Right. Oh, yeah, okay, I see. So, and then, like, and on and on and on, right? Like, I'm saying, like, is it basically, like, at what point does the metadata end up getting bundled in, like, through nesting?
It doesn't. It makes it all the way to the top separated. The bundling, the aggregation occurs between parent and child. As the parent, you aggregate your state and your children's state as one and present that to your parent. And it makes it all the way up to the top where it's so that for any given app root, I want to be able to say this is the canonical state hash. So like the metadata is a form of indeterminism because there are timing related alterations that could have made the metadata be wildly different. Whereas
it's like a quantum thing, right? Like you can't observe the metadata without looking at it, which changes it.
Yeah. And so, well, that's not entirely true. Because we've got this notion now of queries where you can actually observe this, you can read the state of a chain without making a new block. I decided or realized rather that was essential to operation or else you make a fuckload of blocks.
Right. I also think somebody's ultimately always going to be running the blocks. So like they'll always have the ability to read stuff without making blocks.
Yeah. So, but making it a first class operation so that I can run a query across a collection, it allows the query to finish very quickly. This segregation of state and metadata also allows a query index to be formed where I can maintain a DAG of the states, and then I can query that very quickly rather than having to sort of rebuild it every time there's a new thing.
Yeah. I also think like separating it completely and fundamentally all the way to the top of the tree it makes it much more likely that you can chunk off random bits of some child and make a child from it, like in a way that's like easy to understand. I know I've tried to push this in the past
What
before.
do you mean? Sorry?
Like I believe that like if it's correctly designed, the system should result in like kind of like blob growth until you've decided that there's enough structure there that you want to like give it some chain metadata and like push it off into a like a child somewhere, right? Like there's kind of two ways of nesting data in the system that you've defined.
You're talking about during the operation of the system, you make code changes, you upgrade, you migrate, and then one day you're like, oh my god, the state of this chain is ridiculous, and so you split it out into its own.
Yeah.
That's what you mean?
Yeah. And I think if it's correct, if it's correctly designed, it should support like in a very easy to understand and coherent way the idea that like accumulating new data on the chains is always going to be structureless until somebody decides that it's structured. If that makes sense. Like it's one of the things, the reasons people like NoSQL databases is because you're like, I don't care about schema, right?
Right.
But then there's always a point where you're like, okay, now I really care about schema because
allow you to get to the point where you wish for schema, where you ask for it, you long for it. Whereas like a SQL database, you like.
Right, and nobody wants to take the punishment of defining the schema up front because it's brutal, right?
And you're always wrong.
But like, yeah, for sure. Like I think that like a correct kind of picture of state is one that allows you to start as NoSQL and gradually decorate like nested data inside of the blobs that you're making with their own independent chain state. I think that you'll find like that's going to allow data to accumulate and then eventually become governed as its own thing after it's become big enough. Like you throw all your data in a pool and after a while like you find that there's some structure that you weren't expecting in an area of it and that structure requires some extra form of governance. I'm not necessarily talking about code right now as much as I'm talking about the actual like the data that you're collecting from the people that are using the system.
Can I give you an example to make sure I understand it?
Okay.
Let's say you're importing a bunch of data from an existing database. You grab this database dump, say it's like 100 meg. You can then stuff it into Chainland as one big object and then form multiple chains that piecemeal start to eat away at it and pull it off into their individual little structures. But they are able to reference their origin as this particular hash, which is internal to the blob of data.
Yeah, I think you got the picture that I'm trying to.
And then it also allows you to do things like massively multi-thread that import process, right? Because you can just explode out a bunch of worker chains, which can tackle the problem across as many threads as are available to the system, which could number in the hundreds of thousands.
Right. It also allows you to model behavior after you've got the data, right? You don't need to model the behavior before you have the data. In your example.
So really what you're getting at is that as a programmer, it allows you more flexibility over years worth of working with the same data set that's growing and changing and your needs are changing. It lets you be late in when you add structure.
Right. Like if you pull in a table as a CSV file, basically,
Yes.
it's a text, right? But you might come up with this idea eventually where like now I want to represent what it means to be a column. And columns have behavior. They can be sorted, like depending on the data type of the column. They can validate what you're trying to input into them based on the data type. Like they can hold that data type inside them as metadata about the column. If you start unstructured as like a CSV dump and then eventually decide to put rows and columns in like as chain concepts, then like you should be allowed to do that, right?
Yes, absolutely. I can see another benefit that I've only just noticed from talking with you here is that I can switch between, like, because we would be IPLD native and because the state trees would be separate, I can start an entirely new independent chain and reference the state of some other chain or reference the entire state tree of another chain, and I don't get all the chain wrappers around it. I just get a state tree, which I can refer to as though it was binary, and then no one even knows unless you look up the chains that were around the data. Like I could have pieces of state that were wrapped by multiple different chains, and I could do things like I could modify just a slice of that data in an almost alternate reality and then merge back in to this other set where the chain structure of one group is independent of the chain structure of the other until the point of merge back. Like I could manipulate the data as one big piece of state, or I could manipulate it across 1,000 different chains, but it ought not. You know, it looks the same when you use IPLD on it.
Yeah.
And then you can start pulling in actual block chains as though they were state into other chains. So I guess this whole IPLD data format thing completely and definitively solves the problems we used to have with telescoping.
I think so.
Because you can telescope ad infinitum and on purpose, and it doesn't duplicate any data.
Yeah, because it's dealing with everything by reference instead of by like a copy, right?
Yeah, instead of by I'm holding it here, so it is unique. It's like, no, it's like it transforms the reference layer to be universal and stable, as opposed to like depending on what my CPU did last.
Yeah. And you might even be able to do things like grab all of Ethereum.
Well, we need to, right? Because we want to be the connector between everything. And so as it turns out, IPLD is the data model to use to do that. So we're native inside that. We already got a leg up on being able to connect between chains effortlessly. The model I want to approach for connectivity with other chains is that all the blockchains are going to be interconnected, right? Like we all agree on that. It's just that the effort, you don't want an n-squared problem. What you want is a good interconnect format. And IPLD plus, if we were the execution layer on top of IPLD, that makes it sort of like, let's just make it an N problem where you connect to IPLD and then write a processor in our language or, you know, whatever this becomes, rather than trying to connect directly to between chain to chain, point to point, because you don't have enough time to do that.
Right. Yeah, you want to be the communication language between chains, basically,
and
right?
I guess in my fumbly way, I'm trying to ask you the question. It seems so obvious and so nicely fitting. Why is it not done already?
Yeah, like, if you want my honest answer, I'm not sure how like much of a dick I'm going to sound like here, but like the vast majority of existing projects in blockchain land, uh, like exist to try and reproduce like the whole deflationary early investors get rich thing that Bitcoin had.
So they're all trying to pump and dump.
Like,
Except
is there,
IPFS. Except IPFS actually feels pure. It feels like utility and nothing else.
Yeah, because they're just trying to be a hard drive, basically, right? Like a web scale hard drive. Right. So what I mean is like something like Ethereum, I think is making. I mean, there's a few layer one chains like Ethereum and Avalanche and Polkadot and whatever that are like trying really hard to be the execution context for a bunch of other chains, but they're all tangled up. They're all tangled up with coins, right?
They are all tangled with coins. Yes.
And like coins should just be a piece of software you run on your layer one. They shouldn't be like part of layer one, I don't think.
Coins should be an app, not they shouldn't be the internet, right?
Right. And the fact that you don't see any blockchain that doesn't go coin first, utility second. I don't know. I saw a really funny tweet the other day and I shared it with some of my friends. It's like Web 2 is like here, let me just find it.
We are not coin first in your opinion, or we are?
I mean I have no right to change whether that's like the thing that needs to happen, right? The thing is like it's all about whatever incentive actually gets people using the thing. But right. I think there are so many perverse incentives kicking around right now that it's very easy to screw up the incentive question.
Absolutely. I think that we are making a currency, but that currency is there because it's a piece of software that fills a need. It doesn't have a perverse driver to pull you into using it. You can run your own instance, you can issue your own counters or ledgers of it. We're simply putting it there because there needs to be something that tracks relative value between participants, and we're offering it as an NPM package rather than an ICO.
Right. And then eventually it will be the NPM. Like that everything else builds off of, right?
Right? Like if you're earnest about making a pure utility currency, I think you will ultimately eat them all.
Yeah. Yeah, I think so.
But it needs
the only thing is
non-inflation. It must be ultra stable. And the only thing is
the latency. It was so much easier to talk when we didn't have latency. Like, there's probably going to be a coin involved somewhere, right?
There has to be.
I mean, I think otherwise there's no incentive, right?
No, no, that's not the reason why there has to be a coin. There has to be a coin because value must be exchanged between participants because that's how life is. And we need a way to account for that as cheaply as natively as possible.
It's also the n squared versus n thing, right? Like you either have like every pair with everything else has a value, and then it's impossible to understand how values relate to each other.
Yeah.
Or there's like a common medium of value. So what I've read is like the easy way to distinguish whether a coin or any new financial product is like bad for the world is whether it's a negative sum, right? So what you're telling me is like there's a way of building it to tangle it up with actual value creation rather than like what you see on Bitcoin, which is the only money that ever goes into it is money that's coming from somebody else that's coming into it. You know?
Right.
Like, so it's a negative sum game because it means like, you know, two people go into it and like three people come out of it with money and no new money was made in the process, right?
Right. Right. So my dream for this currency that we're launching is to, right now it's going to be 1-to-1 to the US dollar. Eventually, I want it to be leveraged upon the cost of compute units, as it's sort of just like gold is like, well, gold's a gold standard. Compute cost, I think, has the similar ability to be a gold standard because it always levels out. It's always going to be something. You know, it's such a large volume getting done that if you were paying for compute units if everyone's paying for it through the same market, you'll get a fairly stable base to work on, I think.
Right, because
and the
it has the right kind of
is the calculation.
Right. Yeah, I mean that's something that I always wondered with proof of work is like, wouldn't it be better if proof of work was like meaningful work?
Yeah, that and all computing is going to be non-fungible. There's very few problems that are fungible computing problems, like calculating the hash with the longest zeros. Like that's a very fungible thing. Like my work's no different from your work, right? But individual apps have individual executions because they're very stateful. They depend on what I've done in the past, and I expect something different to come out each time. And computing is valuable. I think it's way less valuable than what it gets hiked up as right now, but it's always going to be some value. And I think that's a good, stable, solid, genuine thing to base a currency on.
Right. And the only perverse incentive there is like, let's make better processors.
Is that perverse though?
Yeah, right. I mean, it's not, right? Like, it's actually a good incentive.
Yeah, its incentives go a good way, and so, yeah, we need a currency. We need a currency package or a currency software system to do ambient attribution. We should never ever tangle that up with our own greed for things. It should always be utility first and only utility.
Yeah, I mean, I think, you know, the entire discipline of economics is about figuring out what utility actually is. That's a really slippery question.
Yeah.
But you know what? Like, doing it is better than not doing it.
That's right. Yeah. But the thing I like about the web liquidity pooling is that we don't need a currency to fund our construction, and we don't depend on that currency to make it worthwhile for us to do our job, have done our jobs, right? We're actually selling something deeper than a marker. We're selling actual change, right? Like proof of work, you could say that proof of software work, like we put in genuine effort to make these systems. You can't ever fake that.
I wonder if there's a way to tangle up the incentive to make your software more efficient too.
Yeah, that's the point of ambient attribution. That's the point of ambient attribution, because when someone pays for your software, you get paid based on your contributions. And so someone who makes an improvement or can make an improvement is incentivized to contribute because they will now earn a portion of that royalty stream. And because it was an improvement, the royalty stream ought to get bigger.
I mean, more on the actual compute side. Like, if I wrote a more efficient algorithm, I should be able to go through more like steps in my computations,
right?
Than I would have with a less efficient algorithm. You know?
Yeah. Yeah. So those are the incentives that we're trying to get going with the Dreamcatcher. Is like you can make money by improving, because the one way to look at all this explosion of cryptocurrencies is that I hate sounding like a stuck record, but the thing that seems not really grasped properly yet is that blockchains have to be open source. When you were Oracle or when you were MS SQL, you could keep your fancy new database private and charge people for the results of your innovation, which were higher speed or better performance or better scale. In the blockchain world, you cannot keep that secret. And so what happens is there's an existing chain, someone has a great idea, and they say, I'm going to make my own currency. So they make their improvement, their incremental improvement, launch this new currency. Someone else sees that, makes another incremental improvement, and now there's 3 currencies all competing for attention. Whereas our aim here is to make a single place where it's just more efficient to improve what we have already. It's economically more efficient for you to stay here and just build this thing out, because you'll get a reasonable reward for it without all the risk. But you also sort of have disincentives to fragment.
Yeah, right. Because you can get more done if you work together with people.
Yeah. So I'm trying to make a system that has the right set of incentives to hold everyone together to move forwards on blockchain innovation and deployment in the applications, because it's a huge amount of work and there's a vast amount of ground. We can't have splinter cells forming all the time and diffusing the overall effort, or we'll never get to where we need to be, which is an immutable distributed web and a standard form of computation that's dirt cheap and fucking everywhere, and is able to track the entire planet and model how the fuck we're going to stay alive, given that it's a closed system.
Yeah.
That's a big system.
I think yeah, it is.
It's so big, like it's bigger than the internet right now. It's by like maybe 100x or 1000x to have that kind of system, and we'll never get there if we keep fragmenting as soon as some greedy little piglet sees a chance to make a quick buck.
But how are you going to stop the people that want to do that?
That we're not, but the thing is, because we can pull their innovation back in and pay them for it, like if they get better, we always would have grown at least by the same amount. So
right.
It starts to sort of, the more momentum we can get, the more it starts to become the standard. And it's just like, I haven't heard of anyone trying to make a replacement TCP in a while. I mean, there's one or two, like there's Quick and all that, but like once it gets to that good, it's considered solved, right? Like
yep.
This where we're heading with this architecture does have a solved point. It doesn't keep going with new chains all the time. Like you can't just keep making new chains. Like there is a convergence where the problem is solved and we move on to the next shiny thing.
Yeah. Yeah, I think that's a pretty convincing argument. I mean, I'm not fundamentally against the idea of a coin. I just think that like keeping your politics and your coin and your tech all like tangled together in this big mess is like,
it's evil.
Yeah.
It's evil.
And it's about to be popped too, right? Like I think we should have a good plan together for the time when like the next winter hits, basically.
Yeah. Look, I think we just fucking we just keep going.
Ignore everything else.
Well,
For
like
sure.
what is it really? I mean, our system has utility outside of the value of Bitcoin. Like we are independent of that. Startups are always going to want to access capital to get more done. So, yeah, I don't know. I just feel like we should. It's not like we're gonna like get ready and then pause while we wait for crypto to bounce back. It's like we should just go and just keep going. And because it's
No, I meant it. I meant it in the other sense. I think we need to wait until people are disenfranchised with the bullshit that's going on, and like the next time somebody asks, like, "Oh, like, is there actually any real tech like that's useful in this space?" Like, we're going to be the first thing they find, right?
That's what we want, man. That's what we want.
Yeah.
Like actual genuine utility. And I am so pumped about the fact that putting it on the permanent web by default, browsable by all, kind of feels like we're in the right spot. You know, like even your shittiest of apps has this permanent foreverness about it.
Yeah, no, I'm actually like really pumped to read through this giant blob of algorithm write-ups on the IPLD site.
Yeah, it's crazy, right? It gets super hairy down at the bottom where they talk about distributed computation or distributed queries. It's like that's as far as I've got. But yeah, I think this is the system to use.
You even got some math in here. It's good. I don't know. Yeah, I mean, to be honest, like anything that wants to present like some usefulness for what we're trying to build that goes about it in a way where it's like, here's some algorithms that you could build rather than here's a coin you could get involved with, like, I think is something that we need to, follow and take seriously. And I think this seems like a pretty good foundation to me.
They did make a coin.
Did they?
But they have kept it very separate from the IPFS layer. So, props to them for that. But I feel like it has absorbed a lot of their attention. Filecoin.
Yeah. Is it the same people?
Yeah, same people. I mean, fuck, however they need to get there, right? I just am so grateful that they made IPFS and libp2p and IPLD. And I feel humbled that I never actually understood how powerful those pieces were and how pure and how like effectively base-like, that how basal they are. Like they are the base. That's it. That's the end. No more. Like yeah.
Yeah, because it turns one problem into another problem, right? It turns communication into storage. Like that's why. Yeah, that's why it works, because it's like it's another job altogether to make sure that it's replicated enough that people can actually use it as a communication system. But
yeah.
But it's the right foundational assumption is that once something is done, like it's just stored and it's done forever. And like if you want to understand what happened, like you just look at it.
Yeah. Yep.
I need to think about signing off here.
Sweet, man.
Is there anything that you want me to do, or this
you
seems
could
like some good reading
implement
here.
the permissions layer in IPFS. That'd be super helpful.
Okay.
I guess I'll. I mean, did you have ideas for a simple set of tests? I'm still ogling at this, being like, fuck, where do I start? I might as well just start. Like, I actually feel not at risk here. I'm like, I'm gonna start because this is definitely where I want to end up, and so fucking around with things at the start, I'm kind of like, I should just get in amongst it. It's probably the best way.
Yeah, looking at if you go to the libraries for JavaScript that are in here,
Mm.
or Rust or
Because
whatever.
they're all actually very direct. Like the performance overheads, it's like I can't imagine where those performances are because all the functions are very, very direct. There's not a lot of farting around, I guess.
Right. It's just the math part, and then the meaning part is something you have to put on top, right?
Yeah. So I guess I'll just, unless you can point out, or unless you got some burning questions that might be problems for me, I'm just gonna start doing it.
Sure. I think that's a like I'll post questions as I have them
Yeah,
as I
that'd be
read through the
great. That'd
docs.
be great. I'm just, yeah, I guess I'm just nervous because I'm like, it bothers me that no one else is doing this. But as you say, right, it's like no one else is, very few others are trying to be pure utility. So they all want their coin all tangled up in there.
Well, there's a bit of a discovery problem too. Like you probably wouldn't be able to find the signal of the person that's trying to use this the right way um, through the noise of everyone trying to like pump and dump right now, right?
Yeah, totally.
Like I wouldn't rule it out that there's somebody out there trying to do it, you know?
Oh, there's bound to be. There's bound to be, but it's certainly not. They haven't made contact, a strong contact with the IPFS team.
Right. Yeah.
Yeah. But anyway, I mean, we're trying to make a general purpose compute platform where a coin is just an app on top of it. We're not saying that anyone has to use it or anything like that. It's just an app like any other.
Mhm.
And we're just building in the protocol for how that currency can work. Welcome to just start your own one. It's of benefit to us that it's compatible with ours. That's all.
For sure.
Yeah.
All right. Well,
Okay.
let's talk again soon.
Okay, man. Thank you for your time. Good luck with your race condition.
I hate it. I hate bugs like this.
Yeah.
Just like it has to be an exact. The universe has to smile for you to be able to reproduce the bug. Like,
Yeah, no. That's what I'm hoping blockchains solve for us. We'll see.
or at least help you figure out why they happened.
Well, they're better than logs, right? Replaying the full app state got to be better for you than trying to read a log.
Right.
Okay.
Okay.